Recently, a team of quantum physicists at the University of Oxford published a shocking finding. They discovered signs like resolution limits in space, as if our universe with pixels. According to the report, in experiments measuring the oscillations of quantum particles at the microscopic level, the team found that space does not appear to be continuous, but is meshed like a grid of pixels on a screen. This is not the first time this idea has been raised. Scientists have long asked the question, are space and time continuous, or is it actually a discrete structure like computer data? The theory of a space grid has been around since the 20th century, tied to gravitational quantum theories, where physicists such as Roger Penrose and Carlo Rovelli proposed that the universe could be woven from microscopic space-time fibers of Planck size, about 10 to 35 meters, the smallest unit of physical significance. Recent experiments, such as measuring quantum oscillations in superconductivity or observing signals from the IceCube Neutrino Telescope, have documented perturbations that are difficult to explain if space is perfectly smooth. Some computer simulations have also suggested that space-time pixels can interact like bits of information, creating a noise effect similar to pixels breaking on a screen when zooming in on a digital image. However, direct proof is still challenging because the current technology is not sophisticated enough to measure on the Planck scale, where this grid structure is hidden. If that's the case, is it possible that our reality is not as real as we think? The theory of loop quantum gravity, LQG, offers a bold approach to reconciling general relativity and quantum mechanics by describing space-time as a network of discrete loops made up of Planck-sized space quanta. Unlike atoms, these units do not exist in space, but they themselves create space through dynamic connections, like knots in a cosmic cloth. Physicists such as Abhay Ashtekar, Carlo Rovelli, and Lee Smolin developed LQG into a rigorous mathematical framework in which area and volume are also quantized. For example, the minimum surface area cannot be smaller, 1 narrowed or 70 mu, 10, 70 mu2. Craig Hogan's idea of holographic noise is tied to the holographic principle, which suggests that information about a three-dimensional region of space can be encoded on the two-dimensional face that surrounds it, just like a 3D image on a hologram card. Hogan predicted that if the universe were indeed a hologram, the quantum oscillations on the Planck scale would produce space-time noise, a form of measurable digital noise. To test, the holometer experiment at Fermilab, USA, used two extremely sensitive laser interferometer systems placed in parallel, shining the laser through a 40-meter-long vacuum tube. If the space has a limited resolution, such as pixels, the two beams will oscillate out of phase due to hologram noise, creating variations in the interference image. Although the holometer, active from 2014-2016, has not yet detected a clear signal, it lays the groundwork for future experiments. For example, if interference exists, it will have a characteristic frequency, as MH is, and not attenuate by distance, which is different from conventional thermal noise. Some physicists suggest that gravitational wave telescopes, such as LIGO or ultra-cold quantum instruments, may be more sensitive to this effect. Notably, LQG and the hologram principle, although they come from different perspectives, geometric quantization versus information coding, both overshadow one possibility. The universe can be an information structure where each quantum of space is a bit that contains the universal connection between matter and space-time. The holometer experiment at Fermilab was carried out to find evidence for this, to test whether the universe resembles a three-dimensional projection of a two-dimensional reality. From here, scientists seriously pursued the idea of simulation. Nick Bostrom, philosopher at the University of Oxford, shocked the scientific world with his simulation argument, 2003. Based on three mutually exclusive axioms, humanity will become extinct or self-destruct before reaching the level of post-human civilization. The level of technology sufficient to create realistic simulations of consciousness, like the Matrix. Advanced civilizations have the abilities to simulate, but refuse to do so for reasons of morality, energy, or disinterest. We are almost certainly living in simulation, because if a civilization reaches the point of being able to create an infinite number of virtual universes, the number of simulated entities will overwhelm the number of original entities. Elon Musk reinforces this argument with probabilistic logic. If the universe has existed for 13.8 billion years, while simulation technology only needs a few thousand years to develop, then the number of virtual universes must be billions of times that of the real universe. Therefore, the possibility of belonging to the original reality is extremely low. However, the scientific community is still controversial. Physicist Lisa Randall countered. Simulations don't explain complex natural laws like quantum mechanics or cosmic constants. Meanwhile, David Chalmers, philosopher, argues that even though the universe is a simulation, it is still real in an epistemological sense. More interestingly, some studies suggest how to detect system errors if the universe is computer code. Find the space-time resolution limit, such as Planck particles, similar to pixels in games. The rounding signal in physical constants resembles a floating point error in algorithms. High-energy cosmic ray analysis. If space has a lattice structure, particles such as protons will jerk when moving near the speed of light, creating a digital effect, digital noise, in the data. However, most experiments, such as measuring quantum oscillations in a holometer, have not found conclusive evidence. Bostrom emphasizes that his argument does not assert that we are in a simulation, but only that at least one of the three scenarios must be true. This opens the door to profound philosophy. Is reality a multi-layered concept where layers of simulation overlap each other? Now we're going to compare it to a video game. A universe with a physics engine? In the game, the world is built by an engine, simulation engine, with fixed principles, physical laws, gravity, collisions, render limits, the distance at which objects are visible, behavioral AI, NPCs, and interactive environments, objects that can be destroyed or transformed. Similarly, our universe operates as a much more sophisticated cosmic engine. The laws of physics, such as relativity, quantum mechanics, play the role of source code, governing all interactions from quarks to galaxies. The speed of light, 300,000 km, is the render limit of space-time, preventing information from exceeding this threshold, just as gamers cannot see beyond the render radius of GTA 5. The deeper similarity lies in discrete computation. Game engines process the virtual world frame by frame, and the universe can be calculated through Planck time steps. 1043 seconds, the smallest unit of physical meaning. Some theories even suggest that the existence of matter is similar to how games produce objects only when the player observes. In quantum mechanics, particles do not have a definite position until they are measured. Wave function collapse. The AI in the game partly reflects the self-organizing phenomenon of the universe. From simple rules, life and consciousness arise as a form of emergent property, just as NPCs can develop complex behaviors based on basic code. In addition, glitches such as objects flying through walls or infinite speed are also reminiscent of strange quantum effects. Neutrinos passing through the Earth, or particle tunneling through potential energy barriers. However, there is a fundamental difference. The complexity of the space engine far exceeds any artificial technology. The laws of physics are not only accurate to the millionth, like the gravitational constant, but they are also consistent over 13.8 billion years, without crashing or needing patches, something no game has ever done. Physicist James Gates once discovered error-correcting codes hidden in superstring equations, suggesting that the universe could be programmed in an optimal mathematical language. If the universe is indeed a simulation, the philosophical question is, who or what is running this engine? Is there an outside where the programmer is observing us? Or is the whole reality just a self-simulation loop? From the above studies, scientists have found strange signs in physics, suggesting that this is a simulation. The observation effect in the two-slit experiment is one of the biggest mysteries of quantum. When not observed, electrons or photons act like waves, creating interference patterns, but immediately collapse into particles when instrumentation is available. This is reminiscent of the resource-saving mechanic in the game engine, where the environment is only rendered in detail when the player approaches it, like the trees in Red Dead Redemption 2 appear from the form of a rough grid when you get close. Some theoretical physicists, such as John Wheeler, have proposed that this phenomenon reflects the information nature of the universe. Reality only updates properties when observed, in the same way that computers process data on demand. Physical constants such as the speed of light, cc, Planck constant, patients with chronic hepatitis H, or the gravitational constant, gg, further strengthens the cosmic simulation hypothesis. They act as pre-programmed specifications, setting hard limits for every interaction. Example: cc is the maximum speed of the engine, preventing causality from being breached. Subtle structural constant, A equals E2 for P E0H C1 137 A 4PE0. For the purposes of this regulation, and 2 and 137 regulates the strength of the electromagnetic force. If it changes even 4%, why can't carbon form? Life disappears. Quantum vacuum energy is likened to the background noise of the system, reflecting the quantum calculations that are taking place continuously on the Planck scale. Quantum noise could be an important clue. In quantum field theory, empty space is not really empty. It boils with pairs of phantom particles appearing and then disappearing, vacuum oscillations. This phenomenon, along with the Unruh effect or Hawking radiation, suggests that the universe has a computational substrate that is constantly operating. Physicist Seth Lloyd estimates that the universe has made about 120 calculations from the Big Bang to the present, equivalent to a universe-sized quantum machine. If the universe were a simulation, quantum noise could be noise from these background calculations, similar to the noise of a fan cooling a CPU. The Geo 600 experiment, gravitational wave detector, once recorded a high-frequency noise signal of unknown origin. Craig Hogan called this the echo of quantum space-time. Although unconfirmed, this opens up new research avenues, looking for rounding errors in the laws of physics or the optimization shortcuts that engines use to reduce computational loads. All of this suggests a strange possibility. The universe could be a self-consistent simulation, where everything from quarks to galaxies is the result of an optimal algorithm, and humans, by exploring the laws of physics, are slowly reverse engineering the source code of reality. There are many scientists like Sabine Hossenfelder who argue that simulation theory is unverifiable and therefore not a scientific hypothesis. The question of what computer can simulate the whole universe? Will there be enough resources to do it? Maybe this idea is just a reflection of the current way of thinking. When computers were popular, we saw the universe as a computer. Whether the simulation theory is true or false, it raises a very profound question. Who are we? What are we living in? If this universe were a great game, each of us would probably be characters programmed to aspire to decipher source code, a beautiful paradox of existence. Physical constants like hidden keys, quantum effects like system failures, and life like magic code that passes all tests. They all whisper, reality is not just what we see. Perhaps the mission of human beings is not to find a programmer, but to have the courage to live fully in the midst of a mysterious fog, where every atom and every star is an unanswered question. Just look up at the night sky and ask yourself, is that Milky Way a glittering line of code, or the laughter of a cosmic child experimenting with the first simulated world? Explore, because even in a simulated universe, curiosity is something that can't be coded. Subscribe to the channel so you don't miss the latest videos.